Hi everyone, my name is Alexandra, and in this last video covering observational study designs, I'll be discussing a special category of studies that assess heritability. I'm sure by now you're really sick of hearing me say this, but let me remind you one more time that in observational studies there is no intervention involved. Researchers are simply observing what is happening in a population and collecting data. This means these studies can't directly assess causality, so the study can provide some evidence that a change in the independent variable may cause a change in the dependent variable, but they can't directly prove this relationship. In the case of heritability studies, researchers are assessing how heritable a certain trait is. You may have heard of these referred to as nature versus nurture studies. So we're trying to figure out if a specific trait is more dependent on a person's genetic background or on the environmental factors they're exposed to. In adoption studies, adopted children are compared to both their biological and their adopted families. So we're going to follow this individual here, and this individual gets adopted out of the green family into the purple family. This adopted child has similar genes to their biologic family, but they live in a different environment. So the biologic family serves as a control for genetic contributions to the trait. On the other hand, the adopted family shares the same environment, but has a different genetic background. So here we have same environment, but different genes. And here we have different environment and similar genes. If the trait of an adopted child is more similar to their biologic family compared to their adopted family, that means that trait has a strong genetic contribution, because people who share a genetic background are more likely to be similar than people who share an environment. If, on the other hand, the adopted child is more similar to their adopted family than their biologic family, that means the trait is strongly driven by environmental factors, because people who share an environment are more likely to have that same trait than people who share a genetic background. A famous example of this type of study helped establish that schizophrenia is a disease with a strong genetic component, when researchers found that children with a family history of schizophrenia were just as likely to develop the disease whether they were raised by their biologic or adopted families. Twin concordance studies are another useful way of getting at this heritability question. In twin concordance studies, monozygotic or identical twins are compared to dizygotic or fraternal twins. The idea here is all twins, whether they're identical or fraternal, share a similar environment starting all the way from conception. So these studies are controlled for environmental exposures. So both identical and fraternal twins here share 100% of their environment. But the difference between identical and fraternal twins is identical twins share 100% of their genes, while fraternal twins share only 50% of their genes. So if identical twins are more likely to share a trait than fraternal twins, the trait likely has a genetic component. For example, researchers could recruit a group of participants who have schizophrenia and an identical twin, and they could recruit another group of participants who have schizophrenia and a fraternal twin. If the identical twins of patients with schizophrenia are found to have schizophrenia more often compared to the fraternal twins, that suggests that schizophrenia has a genetic component.